Hello everyone, welcome back to my channel. It's me Raju Bhusal, your physics teacher. In my previous videos, I was discussing some numerical problems with you about dimensional formula, and in this video also I am going to discuss some question about the application of dimensional formula. And in the previous videos, I have already discussed that how the dimensional formula can be used to check the correctness of a physical equation and to establish the physical relation and to convert a system of unit from one system to another system. And in this video now I will discuss about the application of dimensional formula to determine the dimension or dimensional formula of some constant that are used in physics. Here the question is given is determine the dimension of universal gravitational constant capital G and coefficient of viscosity. For this, we first need to find out the formula where these constants are introduced. So after finding the physical equation or the relation where these constants are introduced, we will use dimensional method to determine the dimensional formula of these constants given in the question. Okay, first the question is about to determine the dimensional formula of universal gravitational constant, as we know that this constant was introduced in Newton's law of gravitation, which is given as F equal to G m1 m2 upon r square. Okay, gravitational universal gravitational constant is introduced here and we have to determine its dimension. So we first have to realize or remember or recall the formula where that constant was introduced. This is Newton's gravitational force. Newton gravitational force. And the next formula is and the next formula related to this coefficient of viscosity is of this is also again obtained from expression of viscous force of equal to 6 pi eta r v. This eta is a constant introduced over here. Okay, this is expression of Stokes viscous force. Stokes viscous force. Yeah. First, you have to find out in which equation this constant were introduced. So after finding the equation, then we can put the dimensional formula of the known quantities over there, and we can determine the dimensional formula of those constant. Okay. For in first case, we will determine the dimensional formula of universal gravitational constant, and in the second case, we will determine the dimensional formula of coefficient of viscosity. For that, we first have to remember these two equations. Okay, now for the dimensional formula of G. universal gravitational constant, we have from the given equation we first have to find out the expression of g. Okay, as f equal to g m1 m2 upon r square. From this we can write g equal to f into r square upon m1 into m2. Okay. Now we must use the dimensional formula of the quantities known over here. Now, in dimensional form, g equal to, we must write the dimension of f. F is force here, so its dimension is force equal to mass into acceleration. So and for acceleration, y'all t minus 2. Okay, and as r is distance between center of two bodies, so its dimension is m 0 l square, since there is square, and t 0. Okay, upon, and as m1 and m2 are the masses of two bodies, so m1 equal to m l0 t0, and m2 also dimensionally m l0 t0. Okay. And the numerator will become m here 1, here 0, means m1 plus 0 m1, and l here 1, l here 2, means l 1 plus 2 3, and t here minus 2, here 0, means t minus 2, and upon, we can ignore this 0 term also. Okay, so m1 into m1 m2, l 0 plus 0 0, t 0 plus 0 0, equals to, therefore g equals to yum 1, and that denominator 2 means minus 2. Okay, so yum 1 minus 2 yum minus 1, and y'all here 3, in denominator there is 0, so y'all 3 minus 0 3, and t minus 2 minus 0 minus 2. Okay, thus the dimensional formula of universal gravitational constant, universal gravitational constant is yum minus 1, y'all 3, and t minus 2. Okay, in this way we can determine the dimensional formula of universal gravitational constant. Now it remains to determine the dimensional formula of next coefficient of viscosity. Okay, for that we will use this equation, f equal to 6 pi eta rv. Let's do that. For the dimensional formula of coefficient of viscosity eta, we have formula for viscous force given by stroke F equal to 6 pi eta RV. Okay. Now from here we can write eta equal to F divided by 6 pi RB. Okay. And in dimensional form, above equation takes the form eta equals to here F means force, so force dimensional formula is yom yol t minus 2. Okay, and as 6 is number, so number do not have any dimensional formula, and also pi is a number whose value is 22 upon 7, so it is also a pure number, so it also do not have any dimension. Now it remains for dimension of r and d, as r is the radius of spherical drop, so it is r means length here, so we can write m0 yol t0 for r, and v is terminal velocity, and its dimensional formula is same like as velocity, and in velocity means distance upon time, so m0 yol t minus 1. And this is the dimensional formula. Okay, on solving this we will get is equal to yom yol t minus 2 over yum 0 and yum 0 yum 0 yal 1 and yal 1 yal 1 plus 1 2 t0 and t minus 1 t minus 1. Okay, and therefore eta equals to yum and 0 in the denominator will become minus 0, and 1 minus 0, that's 1, and yal 1 in numerator and minus 2 from denominator, so yal 1 minus 2 yal minus 1. Okay, yal minus 1, and t minus 2 plus 1, that becomes t minus 1. This is the dimensional formula of coefficient of viscosity. Yes, and this is the fourth application of dimensional formula, and in similar manner, we can determine the dimensional formula of other given physical constants also. So this is also one of the major application of dimensional analysis. With this, I would like to thank you all for watching this video till the end, and if you haven't subscribed my channel, I will request you to subscribe this channel and share these videos with your friends as well. Thanks for watching. Bye, have a nice time.